My name is Israel, as Max said. So I'm gonna talk today here about understanding how streaming pipelines work. So my work at Google is in the professional services team. So I advise customers about data projects deployed on Google Cloud Platform. And in particular, I work a lot with Cloud Data Flow and with Apache Beam. And what I'm gonna explain here is actually a part of the experience I've lived helping customers getting the most out of Apache Beam. So when we're working in streaming, needless to say, we are working with unbounded data sources, a data source that is continuous, that doesn't have a beginning and end. And we may think that the problem here is actually keeping up with the load. So if we have like a stream with a lot of messages, so to make sure that we have enough capacity to process all these messages. But normally what the customers I work with are more worried about is about being sure that you are processing all the messages. So when you're working in streaming, you may have problems with duplicates. Sometimes you might be working, for instance, with a message queue that doesn't guarantee exactly one's processing. So some message queues will guarantee at least one delivery, for instance, or will not guarantee order. Also, they are worried about the dropping messages. For instance, when you have late data. Okay, so late data is data that, let's say, arrives very late out of order. And so how to deal with this? Okay, so we are gonna see exactly this. So how to work with this kind of data, even when we have a message queue that it's only guaranteeing at least one delivery and it doesn't guarantee order. But let's see first what is actually late data. In the previous slide, we have seen one string of data with one dimension of data, but in reality, time has two dimensions. Or if we need to think about time in a streaming pipeline, so we actually have two dimensions: processing time and event time. Event time is the timestamp where, like, let's say, when the messages were originally generated. For instance, the actual origin of the messages will mark the messages with a timestamp when these messages were produced. And processing time is the moment that these messages are ingested into our pipeline and they are like assigned another timestamp. So the ideal relationship between these two dimensions is like a straight line, no? So the message is produced at this moment and is processed at the same moment. But the reality is not like this because of different reasons. So the processing will have some lag, like here. Okay, it will happen later than the event time. Sometimes this relationship will be, let's say, closer to the ideal. Sometimes there will be like higher lag for a variety of reasons. The relationship between processing time and event time defines this curve here. It's called the watermark. And this is actually a very important property when we're working in streaming. We may think that late data is data that is late per se, let's say, a message that comes very late. But actually, data is only late when it's compared with the watermark. Okay, so if it arrives before the watermark, it's not considered late. If it arrives after the watermark, then it's late. So, for instance, with this curve that we had in the previous example, so we have like here we have a bunch of late data, late messages. Like some messages are early, like the green dots here, the red dots are late, and then some messages are on time. On time means that they are arriving at the watermark. Of course, when we are sending messages, we cannot know what the watermark is gonna be when our message is gonna be processed. Okay, so this is impossible to know because, like, it would be equivalent to knowing the future, and that's of course impossible. So also in our streaming pipeline, so the watermark is actually an estimation of the actual watermark because we cannot know the future either. So this is also an estimation. So depending on the kind of calculations that we want to do with Apache Beam, this watermark and event time is actually very, let's say, very important. So if we're working in a pipeline that is just doing, let's say, element-wise transformations like filtering, map, and all that, well, so let's say move on and go to another talk because that's really not an issue with for late data or for any kind of aggregation of data. it might be an issue with duplicates, but probably most of the Apache Beam runners will make, let's say, a decent job detecting duplicates and removing them and so on. So this is really not a problem. Now, well, this is actually very simple. So if we want to do like complex calculations, we will have to do some kind of grouping. And if we want to do grouping in a streaming pipeline, we need to apply a window. And when we apply a window, we are actually risking dropping data because we will need to decide how long we will have to wait for late data. And by default, if you don't specify anything in Apache Beam, so you will actually not wait for late data. So any late data would be dropped by default. But we will see how to change this. So let's go step by step. Let's actually first see how to read data. So we need a message queue with messages. So for instance, in this example, I'm including here links to PubSub.io, like PubSub, the Google Cloud message queue, or Apache Kafka, which is also a very popular message queue. So what we need in order to process data in streaming is a value that is time-stamped, okay? And any streaming data source will produce time-stamped values by default. We don't even have to worry about this. So if you have used PubSub.io or Kafka.io or any other input-output module in streaming, you probably have not worried much about the timestamp. So the data have some timestamp by itself, and that's it. However, when we don't specify anything, what we are probably working in is in processing time. Okay, so if we want to use event time, using any timestamp that might be part of the data itself, so we might need to do some additional steps. For instance, let's see the case of PubSub. Although this example would also work for Kafka. So we are reading some messages as strings in this case, okay, from any queue, PubSub.io, it could be also Kafka. We don't care about the timestamps here, but we parse these events, okay, so from the string to some class in this case, and then we are aware that there is a field in these elements that is a timestamp, and we want to use that as our timestamp dimension to reason about time. Well, so we could just produce with timestamps like a timestamped value with this transformation with timestamps. The type will not change, but now the timestamp has changed. Okay, so here, even if it's not explicit, we are using processing time, the ingestion time timestamps. Okay, so every peak collection that it's created from this one will have the same timestamps. The timestamps are not changed. Here, what we are actually changing is the timestamps. Okay, so here we are now working in event time, and this will work with any streaming input-output module. So here is an example of PubSub, but it will work with any. If we are using PubSub, we can actually use the attributes of a message. Okay, so PubSub is PubSub doesn't know anything about the schema of the data that is, let's say, moving around. So it just moves around strings of bytes. So it's, let's say, schemaless in that regard. So when we want to use timestamps for messages that don't have a schema, so we need to publish these timestamps somehow. So normally in PubSub, what we do is we include some metadata that is metadata that is called attributes in the, let's say, in the argot of PubSub. Like for instance, this TS attribute, we set it like equal to the timestamp of the messages that are inside the topic. We need to do this when we publish the messages in PubSub. So it's the original data source, like the upstream data source that is producing these messages, the one that is responsible for publishing these messages with these attributes, so we can actually leverage them. Okay, so in this case, for instance, so these examples that is shown in this slide is coming from this public topic, and you can actually have a look. So you need to decode the messages, but the messages are actually the strings of bytes are JSON encoded messages, the JSON strings. Okay, and you will see that all the messages have this attribute, and it's actually equal to the timestamp of the JSON message that is encoded as a string of bytes. And in this case, it doesn't really match like entirely, just because I couldn't really find the same like messages for both captures, okay, for both screenshots. But if you check it, so it will be actually the same. So if you have this attribute in PubSub, it's as easy as just using this method here with timestamp attribute and passing the the name of the attribute that contains the timestamps, and well, you will be using event time without having to worry more about the timestamps, without having to do any parsing, okay, by relying on the timestamp attribute if the topic that you're using has this, okay. And if you're using Kafka, well, so it has other methods like this one with create time that you can also try to leverage, and other methods to try to set like a timestamp for your messages. Okay. So far, we actually haven't shown much. So regarding late data, so what we have shown so far, you didn't have any risk of dropping any data because we were just processing messages one by one, element wise. Okay. It's only when we apply the window when we are risking dropping some late data. Okay, so in summary, this is the situation that we have. So if we are working in processing time, there is no risk of dropping data, but we cannot do complex event processing either. Like for instance, trying to recover the natural order of the data. So in the window, ordering the data even if it has come out of order. So by using the event timestamps. So we couldn't do any kind of really complex aggregation in processing time. If we want to do that, well, we need to use event time for sure, but then we are risking dropping some data, late data. And this is actually normally very scary because it's actually difficult to be sure that you are not dropping any late data. So let's actually see how you can evaluate this before running your pipeline. So let's evaluate this in a static way, or running like a unit testing pipeline. It's not truly static, but without having to run this in an actual infrastructure and with actual messages. So for that, we need to apply a window. So let's see windows in Apache Beam. So I'm not gonna enter into a lot of details here. So there are lots of details in the Beam programming guide. There is an excellent book, Streaming Systems, that explain this very much in detail. So we need to apply a window to be able to make some grouping. Okay, so the kind of window we don't care. So what we are gonna explain here is it can be applied to any window. Now, it's sometimes difficult to understand how streaming and windowing works, like with triggers, with allowing late data, with aggregation modes and all that. So we are gonna see how to use unit testing to evaluate what's the behavior of a window, whether it's dropping late data or not, and how the different triggers are working. Because when we define several triggers for a window, we will have actually for each one of the windows several outputs. Okay, and this is also sometimes that is confusing sometimes also, so that you have more than one output per window. Okay, so this GitHub repo has some code that I'm gonna be using very briefly in the coming slides. So it's actually, let's say, not something very complex. It's using the test string class. The test string class is very interesting in Apache Beam because it's like a string that you can use for unit testing, and you can control not only how the messages arrive into the test string, you can also control how the watermark changes with each one of the messages. And if you control the watermark, you can actually very easily generate on-time data and late data. So how do I did that? And if you look at the code, you will see that the unit test that we're gonna use here is using 50 on-time or early messages and 10 late messages. So we put the 50 messages first in the test string, then we progress with each one of these messages. We make the watermark progress, then the watermark has advanced quite a bit, and then we take 10 messages that have timestamps similar to the messages that we just ingested, and we ingest it after we have changed the watermark. Now, these 10 messages will be late because their timestamp is after the watermark. Okay, so again, remember, messages are not late per se. If you want to make a unit test and you want to generate late data, you don't have to put like an ancient timestamp. You just need to control the watermark and make sure that the messages that you're introducing in the string is that these messages have timestamps that are after the watermark. But you control the watermark, so this is actually easy to do. And then in the unit test, what we actually make is just counting messages and creating sets of messages. So because the window may be triggered more than once, depending on how you define the triggers, and the unit test, it's that we are gonna show now. It's agnostic between agnostic about the window that you are using. So you may have several triggers for the same window. So it's important that you calculate the number of messages that you see in the output using sets, because the same message might be like part of the output more than once. Okay. So, and if you have more than one trigger, that will be the case. So let's actually see it in action. So I'm not gonna run it because the talk is I don't have a lot of time in this talk, but you can actually just download the repo, and if you are using Maven, just run Maven test or MVN test. For instance, if you try it with this window, and this is a link to the repo. This is one of the windows I have provided in the repository. I don't know if it's readable in the screen or not, but it's using this with allowed lateness standard days 10 days. Okay, so this is like a little bit exaggerated because the messages I have generated, so they span only like around 1 hour. Okay, so 10 days of lateness means that no late data of the one that I have produced manually will be dropped whatsoever. Okay, and then the test passes. Okay, so I'm sure that the window with this test data that I have generated with this window will never drop data. For sure, I would have to fine tune the test string to have messages that look like the messages I'm gonna receive. So I need to know some properties about the potential late data. So how late can late data be? Okay, like 1 day, 1 week, whatever. And then so adjust the test string to look like real data. I could, for instance, capture real data from production and then use that as a part of the test string. And also I can use that information to actually decide about the window. In addition to checking whether the window will be dropping late data or not, the test will also write some output with all the triggers of the window, and we can actually reason about how the window works. Like the window that we have right now on the left side. So if you explore the output, you will see something like this. So here in two colors, we have two different windows. Okay, I have used colors for two different windows, blue and yellow. The yellow window is smaller. It doesn't have so many elements, and it has only one early element and one on-time element and no late data. The blue one has a lot of early messages, one message, one trigger at the watermark. Okay, and if you go back to the previous slide, you will see that we were actually triggering at the watermark. That's why we have on-time messages here or on-time triggering here. And then it has, after the watermark, all data is late. Okay, well, this is fine because we are not dropping any late data, and we see that the messages before the pipeline were 60, and the messages after the pipeline are also 60, meaning that we haven't dropped any data at all. Okay, so all the data that we put in the input has been part of the output somehow. Okay, so this is just, let's say, an if aggregation in this case, but any kind of aggregation that we would have made would have included all the 60 messages together. If we do like a different window, like this one, so here the allowed lateness is just 0, so no late data is allowed. When we run the test, so it fails because it actually expected 60 messages because we put in the input 60 messages, and the output had only 50 messages because in this case, so I decided to make 10 messages late. And if I go to the output, okay, so I'm missing here one last line, okay, but for all the 60 messages here, but you see that the input had 54 messages in this case, like in this trigger in this window, and the output had only 50 messages. Okay, so here again I'm using different colors for different windows, and you see that no window had late data. Okay, so there were like early on time, and then another window opens, and these are all fixed windows. Another window opens, and then when when we trigger at the watermark, another window is open, and so on. And then the output will only count 50 messages in total. So we are missing messages. Okay, so we're almost finishing. Sometimes we may need to find out how different triggers work, okay? And this might not be trivial sometimes. Like, for instance, I remember once I got a question about after each in order, and I was like, well, I have no clue about how this actually works. No big deal. Just create a window with the triggers that you want to find out how they work and inspect the output. Like here, So we are producing output when we have 3 elements, then when we have 10, and then every 10, every 15 elements after that. Okay, so we have here like 3, then 13, and then every 15 elements. So it's clear how it works, and really, really like no mystery here on how this works. Okay, so almost done. Take away now. So if you just join the stream, or you just wake up after like a boring talk. So these are the important parts that you must remember. Okay, so later when you talk to your wife, your husband, your family, when you go home, your friends. So these are the points that you have to tell them. So time has 2 dimensions: event time and processing time. And if we want to do complex calculations, we need to use event time. For that, we have to use the right timestamps for event time processing. Okay, so we need to pay attention to which timestamps we are using. Otherwise, we will be using processing time. But now, when we are doing that, so we are risking dropping data. Okay, so it's very versatile, but you need to take care of the late data. That's really not a big deal, because you can use unit testing to ensure that you are, or to assess whether you are dropping data. Okay, like we have shown. And actually, you can just leverage this repo that I have here, and also inspect the output to see how the different triggers of the window look like. And anytime that you have one question wondering how a particular type of window works, or how a particular trigger works, or like several triggers in combination work, so you can just run the test and inspect the output to actually just have a look at that, how that works. And I think that's it on my side. So, well, thanks all for your attention.
Thank you, Israel, for the talk. That was really interesting. I think, do we have time for Q&A, or are we out of time? I'm not 100% sure. I think we probably have time for another question. Let me take a look. Okay, so I actually have a question. What if I want to assign watermarks myself? Is there anything I can do to ensure that I don't drop too many events, or what would be a good way to assign watermarks for like real time events that arrive?
Well, and I will focus on the case of PubSub and data flow. So data flow and PubSub, let's say they estimate the watermark in combination, and you cannot really influence the estimation of the watermark. So that will be what it will be. But something that you can do is, for instance, before you apply a window, you can tinker, let's say, the timestamps, because well, you have some notion, so you can keep track of the messages you have seen so far. So you can keep track also of like an estimation of the watermark, and then so like modify that timestamp to make sure that it will be always before the watermark, and then so you will not be dropping any data. So this is something like we have done sometimes with some customers. It's not entirely, let's say, recommended, because a streaming pipeline will drop late data for a reason. So like if you get like very old late data, so you will be actually getting like like highly manipulated data, let's say. Okay, but if you are really worried about not dropping a single message, so that's something that you could do. So like tinkering the timestamps before applying a window.
I see. That makes sense. We have another question here from Slack. When an unbounded source doesn't provide an inbuilt event time from attribute like Kinesis.io, so I guess he means it uses ingestion time. Is any documentation available on how to tune the watermark policy so that with timestamp p-transform doesn't fire off a runtime exception? It might be a little bit of a tricky question here. Not sure I 100% understand it.
It sounds tricky to me, yes. So I don't really know Kinesis IO in detail. So the the when an unbounded data source needs to provide like a timestamp value somehow, or and if it doesn't provide like a timestamp, then so you will not be able to work in a streaming in event time. So using that data input, I think. But I guess this is like a question for the mail group or something like that. Because
Right. I think it's best to answer this question in the Slack channel.
Or in the Slack, yeah.
All right. Then just want to say that we will have a networking event now. There is a platform called Gather Town. We will post a link in the Slack channel where you can meet people and talk to them. So please join us in the next 2 hours for the networking event. And thank you so much, Israel, for the great talk.
Thanks for having me here.
You're welcome.